Hi, welcome to this video on data mining project methodology. Hope you enjoy. Project methodology. CRISP DM. It all looks kind of daunting, but you'll find it is a handy reference that you can use when working your way through a data analytics engagement. So CRISP DM stands for Cross Industry Standard Process dash data mining. There are a number of other CRISP methodologies, but the CRISP DM1 is the only one I've actually encountered and seen used in practice. In my experience, there may be others in use. Other methodologies are typically used for software development, which is what I've worked with in the past. So anyway, CRISP DM, you can see just through the diagram, it's circular. It kind of cycles through again and again. And you'll see as we work our way into the tasks that the tasks can iterate back and forth and even go back multiple steps. So this is definitely not a linear process. It's got a linear nature to the actual methodology, the way we step through the steps. But as you can see, at any one time, we may decide we need to go back several steps and work our way through that in more detail. And we may even scrap the project at any point in time. So we begin with phase one, which is business understanding. And the idea here is that we're trying to figure out just exactly what the problem is, what kind of ways we might be able to address it. How would someone use a solution? How would we put it into place? Is it even feasible? One of the examples that is discussed in one of the readings talks about how nurses were part of a project and they found that, sure, we can increase the accuracy of our diagnoses and the outcomes of people in the ER if we add this additional step, but they weren't willing to add that additional step to the ER routine. It slowed things down, and as a result, it just became something that was unfeasible. Here you start exploring and discovering the problem. What kind of data is there? What kind of data can you imagine? What kind of data do you think you might need to create? How accurately can we predict something? What impact will these predictions have on the organization? So being able to get some good findings in all three of these areas are important to have a good project. If you only have two of them, then you need to figure out, well, what can I do on that in that third area to help the project out? And we can start breaking the problem down, looking at potential sub-problems. Each sub-problem may even have a different technique or different type of set of techniques that can be used for that solution. And you can put those back together at the end into what we call ensemble methods. And we'll talk about those later on as well. So this phase of the project, and all these phases are going to have deliverables at the end of them. A deliverable is basically an output of that phase. So here you can see we want to determine what the project objectives and success criteria are going to be. We're going to review the current situation. What kind of resources do we have? What data do we have? Do we have the expertise? Do we need to bring in some outside help? Do we have technological resources? Do we have the right software tools and all those types of things? What requirements do we have? What assumptions do we need to bring into play? What kind of constraints might we have on what we're able to do or what we're ethically allowed to do? What we're obligated to do? What kind of risks are there? Can we put some contingencies in place to address those risks? Specialized terminology we'll use for the project. We want to make sure we understand that. And then at this point, we can even do an initial cost benefit to kind of get a feel for, is this something that's even worth pursuing? Is it going to bring some kind of a benefit? Can we see some kind of a benefit there for us? And at that point, we can start building the project plan. And there are all kinds of project planning tools out there. Microsoft Project, Project Workbench. There are a bunch of web-based project management tools that are out there. You can put together Gantt charts, PERT charts, you name it. So And in many cases, the CRISP DM activities will be a sub-project in part of a larger effort in the organization. Okay, so that's the business understanding. And from here, we move into data understanding. And at this point, we start to do what we call in statistics EDA, exploratory data analysis. We start to analyze the descriptive statistics, look at scatter plots. Can we see anything? Are there any, easily identifiable trend lines? Let's put out a correlation matrix and see what variables are related to other variables. Can we use that to our advantage? Do we need to eliminate some? So forth. What kind of labels can we identify? These would be the target variables that are of interest. What kind of label variables can we identify that can help us in our pursuit? And at this point, we can start to identify what techniques are going to make sense for our problem. So, one of the examples that you read about had to do with fraud. And when it comes to credit card fraud, well, that's fairly clearly defined. You have transactions that come from specific places or specific stores that you can identify fairly clearly as fraudulent. So you have good labeled data that you can build a data mining solution for using a supervised approach. Health insurance, on the other hand, is a lot more nebulous and tough to identify. Health insurance fraud. You've got lots of different players there. Patients can commit fraud. Providers can commit fraud. The labs can commit fraud. So you've got a lot more of an unclear distinction between fraudulent and valid transactions. So in this case, exploratory techniques may serve us better. So the output here, we start to list out our initial data collection. What kind of data sources do we have? And then we pulled it together, a description of that data. What kind of data do we have? What format is it in? What are the acceptable values? Things like that. And we can start with our data exploration. What have we been able to find out so far about the data? And we can include visualizations here as well. Scatter plots, trend lines, things like that, correlation matrices. We can also start to report on the data quality. Is the data quality, are there a lot of holes in the data? What kind of problems may exist? And we can start exploring different solutions we can apply to any data quality problems that we have. So that brings us to the next phase, and that is data prep. So here are the activities, the ETL activities that we've already talked about a couple times. And extracting is a pretty straightforward approach, just depending on identifying the data source and putting the appropriate tool in place, whether it be a database query tool, something from Hadoop, a flat file, Excel, so forth. So the extract and then the loading it into the end tool are usually pretty straightforward. So we dive into the muck when we get into the transformation. So key transformations that we may perform: text to numeric, categorical to dummy. We may have to remove values or even records with missing values. Or we may decide we can infer some values. We may need to take numeric data and scale it or normalize it with some other method. We may transpose columns to rows or vice versa if it suits us. We may do some other transformations, nonlinear transformations. We may square variables or apply some exponent to them. We can do what's called feature selection and feature engineering, where we actually build new features that we can evaluate. So the deliverables here are going to be a data inclusion and exclusion report that allows us to identify what data we decided to keep, what data we decided to eliminate from further analysis, a data cleansing report, what kind of things did we do to scrub the data, supply missing values, things like that. How did we deal with outliers? What kind of transformations did we have to do? And then the new records and attributes that we may have created. Were we able to derive attributes? We'll talk about a technique called principal components analysis that allows us to basically build new attributes from the existing attributes. Did we generate new records? So, for example, we may want to identify customers that did not make purchases. So we may have to generate a record for customers that didn't have a purchase and populate all the values with zeros, for example. So generated records, and then we have a data integration report that we create from that. How did all the merged data look when we were done with it? And then what kind of aggregations did we conduct on the data? What kind of summations, what kind of calculations, what kind of ratios did we create when we pulled the data together? All right, so that is data prep. And at this point, we're ready to begin modeling. And here's where we actually start mining the data. We start applying those data mining techniques that we think make sense. We may apply some additional ones as well. And then we can start tuning our models. We're going to calibrate the parameters. So most models come with a lot of different parameters that you can set as you run the model. So we can tune those parameters, figure out how the model fits, what kind of quality we're getting from the model output. And here we end up with deliverables based on what we find through the modeling efforts. What kind of modeling technique did we find that was best? What's the algorithm we would like to move forward with? We'll probably include a list of other finalists as well. What kind of assumptions go into the inclusion of this model? Do we need to have data with a normal distribution, for example, or do we have to always provide some kind of transformation? How did we test the model? So we want to be able to show the design of the test and how we set it up for training, testing, validation, and all that kind of stuff. And we'll get into that in a little bit more detail later on as well. Once we identify that trained model, what are those parameters that we did define? What are the parameters that need to be set, and how do they need to be set when we run the model? And here again, we can report the results of different models that we tested and show why we selected the one we want, as well as a description of the competing models as well. Finally, we assess the model with respect to the other models in place, and how we're going to move forward with that. So we can include things like accuracy, area under the curve, which is something we'll get into, what kind of errors, what are the impact of false positives, false negatives, and so forth with respect to our model. Next, we evaluate the model. We assess the results that we've come up with. Can this model achieve the objectives that we set out for it? Is this model going to be valid and reliable? In particular, once we put it into a real-life scenario. Again, false positives for fraudulent transactions can be problematic because you don't want to deploy a lot of resources chasing down a lot of false leads and possibly getting discouraged and putting less effort into what end up becoming real leads. So you want a good, strong evaluation framework in place. And at this point, you can update the cost-benefit analysis as well, now that you have a little bit more information about what you can expect from this model. So we assess our results. In the deliverables, we're going to hopefully end up with a decision on the use of the selected model, how it's going to be put into place, and so forth. And here we can also list out the other approved models, maybe rank them in order so that we can make a final determination. We'll also document how the different models were reviewed in that reviewed process, and then determine what the next steps will be. What kind of actions do we have as alternatives, and then which one did we decide to go with? And at this point, you want to make sure that that decision is signed off and approved by the various stakeholders. And then finally, we deploy the model. And all that means is we put the model in place and start using it. So it's not really that difficult to put a model in place and use it anymore. And you're going to find that out in this course. You're going to actually put a model in place that you can use in an Excel spreadsheet as part of this course. So you can imagine it's pretty straightforward for an organization with solid IT resources to do so as well. So the deliverables here, we're going to have a deployment plan that merges back in with the regular IT development plan, project plan, to get the model in use. You want to have some way to monitor the model and the output of the model, the results, and maintain it on an ongoing basis. Is this going to be a machine learning model that updates itself, or is it going to have to be something you refresh from time to time? You'll put together your final report, presentation to the various stakeholders as you put the model in place or right before you put it in place. And of course, you want to have good, solid documentation of the model itself for future users. So this is a real quick overview of CRISP DM. Now, regardless of whether the deployment is successful, the process will often go back to business understanding. Because the team has been through the cycle once and started doing some data science, applying data science techniques, they're going to gain a lot of insight and may come up with other business problems that can be addressed with future iterations of this cycle. So that's it for our overview of CRISP DM. Hope you found the video useful, and be sure to check out the other videos available in this series.